Hi, welcome to JEE Chemistry Tutor. In the last class, we have seen that to explain the experimental findings of blackbody radiation, Planck has introduced a concept of quantization energy. It said that energy is discrete and not continuous, which contradicts with the classical physics and opens a new era in physics. And we have also discussed that Einstein has employed the concept of quantization of energy to explain the experimental findings of photoelectric effect. And this experiment of photoelectric effect shows that light also can have particle characteristics, and which coined a new term, photon. And if you didn't watch our first two lectures, please go and watch it. The links are given in the description box. And if you like our videos, then please subscribe and share it with your friends, and don't forget to press the bell icon to get the further updates. From the last two class, we have understood one point, that theories are made to explain the experimental findings, but not the opposite is true. In this context, I would like to quote Professor Max Planck, who said that experiment is the only means of knowledge at our disposal. Everything else is poetry and imagination. In this class also, we will see another experiment, that is line spectrum of hydrogen atom. And we have already seen that Rutherford's atomic model couldn't explain the line spectrum of hydrogen atom. Let's see what this line spectrum of hydrogen atom are and where it contradicts with the classical physics. Electric discharge were applied in a tube where the hydrogen gas are there. Then it radiates some energy, and the wavelength of when the wavelength of this radiation were measured, the results were quite surprising. Why? There are only 4 lines at that time, and the wavelength of that lines were 656 nanometer, 486 nanometer, 434 nanometer, and 410 nanometer. There was no line in between these 4 lines. This was quite surprising. The classical physics says that when a charged particle moves, it should irradiate radiation continuously. So here, the line spectrum of hydrogen atom contradicts with the classical physics. Scientists at that time were puzzled with this. They were trying to find out why these 4 only, and what is the physics behind it. Then at the beginning, the scientists were trying to arrange these 4 numbers in some series. They are trying to find out some formula so that they can find out the other radiation also. The Bohr, who was actually a mathematics school teacher in Basel, he found out one empirical relation that correlates these 4 frequencies, 4 radiation. How he got this formula? So he saw that this wavelength, he can arrange this wavelength in some fraction of one Bessel number, and he find out that these 4 wavelengths can be arranged in this way: 9/5b, where b is one of the Bessel numbers, and then 4/3b, 25/21b, and then 9/8b. Saw that this numerator, that numerator can be represented as 3 square, this is 4 square, 5 square, and 6 square, and that of the denominator is like 3 square minus 2 square, and this is 4 square minus 2 square, and this was 5 square minus 2 square, 6 square minus 2 square. So here he generalized this, he got the formula that lambda is some Bessel number multiplied by n square minus 2 square, where n equal to 3, 4, 5, 6. And he predicted the fifth line, means that when n equal to 7. And later it was verified experimentally also. After few times, a Swedish physicist Rydberg published a paper on transactions of the Royal Swedish Academy, where he claimed that he was using this Bohr's formula long time before this publication. And he stated that in the spectra of all elements analyzed so far, there are a series of rays whose wavelengths or wave number are function of consecutive integral number. And he has given the formula that the wave number nu bar equal to 1 by lambda equal to some constant which is known as the Rydberg constant by 1 upon n1 square minus 1 upon n2 square, where n2 greater than n1. Now for the hydrogen atom, to match the experimental data, he got the value of this constant is 109677 centimeter inverse. Now we can see that the Bohr's formula, this is just a special case of Rydberg's formula when n1 equal to 2 and n3 equal to 3, 4, 5, 6. Later scientists have discovered many other lines in the hydrogen atom spectrum, and it follows the formula of Rydberg's empirical formula. So, and we can see that among this line, only the Bohr series falls under visible region. So, from this empirical formula given by Bohr or the Rydberg, we can predict at which wavelength we should get the hydrogen atom spectrum. But the question remains that what is the physics behind it? It was not clear from those formulas. Those are just the empirical formula. But the physics was not clear. So it demands a new theory to explain the physics behind this line spectrum of hydrogen atom. In 1913, scientist Niels Bohr gave a new theory to explain the spectral property of hydrogen atom. Before going to the Niels Bohr's theory, we should look on the major discovery that led Bohr to propose a unified structure of an atom. Here it is important to mention that it might happen that one theory might have some drawbacks, and this theory have been discarded by the new one. But still we should read those theories because these theories are the building block of the new theory. Before going to the Bohr's theory, let's look on the major discovery that helps Bohr to formulate his own theory. The first is the discovery of the cathode ray. And after that, Thomson measured the charge by mass ratio of electron, and Mulliken measured the charge of the electron. And we have seen that the Rutherford Goldpoint experiment, that there might be many drawbacks, but this is the first time someone has told about the concept of nucleus, where all the positive charges are concentrated. And then we have seen that the Planck gave an idea of quantization E equal to NH nu that would explain the experimental fact of black body radiation. And then Einstein borrowed the concept of quantization of energy to explain the photoelectric effect. And recently we have seen that the atomic spectra of hydrogen atom that are discussed. Now, all these theories, all these discoveries, major discoveries, helped Bohr to formulate a new theory that could explain the experimental behavior. Now, in most of the textbook, you will find that Bohr theory, they have represented Bohr theory is just as a theory to calculate the energy and the radius, but really it is not. And in most of the textbook, you will find out they mentioned that the angular momentum is quantized. You will find out that mvr equal to nh by 2 pi. So angular momentum is quantized is one of the postulates of Bohr's theory. But believe me, in the actual paper of Bohr, he never postulates the angular moment, quantization of angular momentum. And the concept of quantization of angular momentum came as a consequence of Bohr's theory. In this class, I will try to give an overview how Bohr had developed his theory. Let's see the development of Bohr's atomic theory. Niels Bohr moved to Cambridge from Denmark to work under Professor J.J. Thomson. He was trying to build a unified model of an atom. He believed that if we could implement Planck's idea of quantization with Rutherford's atomic model, it could explain the hydrogen atom spectrum. But unfortunately, Thomson found this Bohr's revolutionary idea hard to accept. Because of this thing, in 1912, Bohr moved to Manchester from Cambridge. There he started working under Rutherford. Here the question is, why should Bohr have chosen Planck's idea of quantum as the way to go? And because of that thing, he left Cambridge and went to Manchester. So Rutherford's idea of a solar atom, where the electrons circle the nucleus, sound promising to Bohr. He felt that any theory which tried to explain the stability of an atom would yield a constant, which is the dimension of length, and would describe the distance of the nuclear electron from the center of the stable orbit. But Bohr found that if he could combine the Planck's constant, mass, and the charge of the electron, he could get a constant that has the dimension of length. He combined in this way, h square by m square. Now if we put the value of h, m, e, we could get that value of the h is 6.626 into 10 to the power minus 27 arc second, its whole square, and the mass of electron is 9.1 into 10 to the power 28 gram, and charge of electron is 4.8 into 10 to the power minus 10 square. This is in the ESE. Now if we could simplify this, we will get almost an 10 to something multiplied by 10 to the power minus 8. Now if look that this is almost comparable with the atomic dimension. Now this idea of Bohr seems rather sketchy, but it gives an indication to Bohr that his theory is tending to fruitful approach. Believe me, just bear with me for a few moments. You will soon appreciate the beauty of a great theoretician's thought process and the methods of problem solving. Now, every theory is based on some of the postulates, and postulates are the building block of any theory. Let's see what Bohr has postulated for his theory. Bohr daringly proposed that electrons do not radiate energy as they orbit the nucleus, but exist in states of constant energy, which are called stationary states. So these are our stationary states. And they can only radiate their energy by undergoing a transition from one stationary state to another. During this transition, they emit or absorb amount of energy which is exactly equal to the energy difference between the two states. And this behavior produces the characteristic spectral line. Now this is the Bohr's postulate. Now in this postulate you can see there is nowhere it is written that the angular momentum is quantized. Again I am saying what most of the textbook use, that the quantization of angular momentum as one of the postulates of Bohr theory, but it is not. It is the consequence of Bohr's theory. What Bohr needed to do was to formulate an expression of energy that could match with the experimental findings of hydrogen spectrum. So for this, he thought that though the electrodynamics, classical electrodynamics failed to explain the line spectrum of hydrogen atom, but the classical mechanics can be still applied. when an electron is circulating the nucleus at a velocity v and the radius of the circular orbit is a, then for the stability we can write that the centripetal force mv square by a should be equal to the E by a square. That is the attractive force of the electron and the nucleus. Here E is the charge of the nucleus what Bohr used, and for matching with the usual stress book I am writing E equal to ZE, where Z is the atomic number, and so mv square. So from this relation we can get mv square equal to ZE square by A. Okay. Now the total energy of the stationary state is the kinetic energy plus the potential energy, and kinetic energy is half mv square plus the potential energy can be calculated. So it can be calculated by integrating the expressions of the Coulomb's attractive force A Z square by a square into dA, and it would be minus ZD square by A. Okay. So it is plus minus ZD square by A, and from this relation we can find out what is half mv square. So half mv square becomes ZD square by 2A minus ZD square by A, and it would give minus Z square by 2A. Okay. Now this is the total energy of the orbiting electron, and where the radius of the orbit is A. Now if we sublime this amount of energy, we could remove the electron from the attractive rule of the nucleus, and Bohr called this as the binding energy, and it is Z square by 2A. Now from here you can find out that A equal to Z square by 2W. Now this electron is rotating, so it has some angular velocity also. Let's find this W omega. Omega is the angular velocity. Now so V equal to 2 pi omega into A. Now my W equal to half mv square. We could replace V here, half m into 4 pi square omega square A square. So it becomes 2 pi square m omega square, and we could replace A by Z square by 2W. So it becomes Z square e to the power 4 by 4 W square. So my W now becomes pi square m omega square into Z square e to the power 4 divided by 2W square. So here from here we can find out the angular frequency, and that is the omega square equal to 2 omega cube divided by pi square m Z square e to the power 4. So my omega is 2 W cube pi square m Z square e to the power 4 to the power half. So from here we got the expression for omega, the angular velocity. Now here we will note down this value, omega equal to 2 W cube, and this is pi square m Z square e to the power 4 to the power half. Let's take it once again, 2 W cube pi square m Z square e to the power 4 to the power half. Okay. But till now nothing was more than classical. Here Bohr faced the problem. He has to incorporate the Planck's quantum theory to explain the hydrogen atom spectrum. For this he proposed what Planck proposed for his blackbody radiation, that the energy of the emitted radiation is nh nu, and what Bohr proposed that the energy of the emitted radiation, equal to NH nu dash. Now n is any integer and nu dash is the frequency characteristic to electron rotational motion. Characteristic to electron's rotational motion. Now here we find the problem how he could relate this nu dash and omega. How he could relate these two. According to Bohr's second postulate, the energy of the emitted radiation will be equal to the energy difference between the two states. Now he assumed that the electron is coming here the nucleus, electron is coming here from an infinite distance, and from an infinite distance the energy is 0. So here W minus 0 is my NH nu dash. So my W equal to NH nu dash. But this nu dash, it is not necessary that it could be equal to the energy of frequency of the emitted radiation. But Bohr proposed that in his case, for transition of between the two states, that nu dash, it would be the average rotational frequency between the two states. And since at infinite distance omega is 0, so for this the average it would be omega by 2. So my W becomes NH omega divided by, my W becomes NH omega by 2. Now here this relation is little bit contrary. In fact it is. Actually Bohr was not able to reach able to form any successful theory until he looked on the Bohr's formula. After looking at the Bohr's formula, he began working backward until he got this huge factor 2. So this factor 2 is coming just to match with the experimental finding. Now if we replace this omega value of this here, so we could get what. Now before going to this, let's just square it on the both sides, so it becomes n square h square by 4 omega square. So it becomes n square h square by 4 into here the omega square means 2 divided by pi square m z square e to the power 4, looking like n square h square divided by 2 pi square m z square e to the power 4, or W is going equal to be 2 pi square m z square e to the power 4 by n square h square. So this is the expression for the binding energy of the electron. Okay, now you can see that here that binding energy is inversely proportional to n square and proportional to the z square, means the atomic number. We can also find out the characteristic radius also, equal to z square by 2a. So my radius is a equal to z square by 2w. Now if I replace this as w, so z square by 2 multiplied by n square h square by 2 pi square m z square to the power 4. Do the simplification, it would look like n square h square by 4 pi square m z square. Now here look, if we just write the radius in a more arranged manner, n square by 4 pi square m z into h square by m, sorry, there should not be any m here, m square. Now look, what Bohr thought at the beginning came into the relation of the radius. So this h square by m square, apart from this constant value, it came in the expression of the radius. Here lies the beauty of a great theoretician's thought process. He thought this before, and again it is coming in his mathematical relation. The more success of the Bohr's theory was it could explain the hydrogen atom spectra. Now for a transition between two states, lines corresponding to their energy difference would be emitting. So my W in F minus W in I should equal to h nu, where nu is the frequency of the emitted radiation. Now so if we means the expression of W, so it becomes 2 pi square m z square e to the power 4 divided by h square, so 1 minus nf square minus 1 upon ni square equal to h nu, or nu equal to 2 pi square m z square e to the power 4 divided by h cube into 1 upon nf square minus 1 upon ni square. Now we could rearrange it, that is 1 by lambda, or the wave number, it would become 2 pi square m z square e to the power 4 divided by ch cube into 1 by nf square minus 1 by ni square. Now this is my Rydberg constant. And for hydrogen atom, that z is 1. So Rh is equal to 2 pi square m e to the power 4 by ch cube. And if we put the value of what we used for the now, we will get that it becomes 109,760 centimeter inverse, which is close to the experimental value, which is 109,677. So this is the great success of Bohr. Now the another thing, it is worthy to derive the expressions of the angular momentum. Now angular momentum is m equal to mva. Now we can rearrange these as half m v square into, so v will be here, 2 pi a into 1 upon 5. Now half m v square, this is our kinetic energy, into 2 pi v equal to 2 pi omega a. So my 2 pi a by v equal to 1 upon omega. So it becomes t by pi omega. Now t, here the t is half mv square, and that is equal to the w, and we have seen that from both formula. So it becomes w equal to n h omega divided by 2. So n h omega divided by 2 into 1 upon pi omega. So it becomes n h by 2 pi. Here comes the quantization of angular momentum, which oftenly used as the postulates of Bohr theory, but it is really not. So what is the take home message from this class? So what we have learned in this class is that hydrogen atom shows discrete line spectra, and the wavelength or wave number for any transition can be determined from Rydberg's formula, which is 1 by lambda equal to r1 to 1 upon n1 square minus 1 upon n2 square. And we have learned about the Bohr's theory. Please remember that the quantization of angular momentum is not the postulates of Bohr theory. That is just a consequence of Bohr theory. And we have find out from the Bohr theory that the energy is 2 pi square m z square e to the power 4 by n square h square. So E for a particular n, E is proportional to z square, and E is inversely proportional to n square for a particular z. And for the radius, it is just opposite. For the radius, A is proportional to n square when Z is a constant and A for it is proportional to, inversely proportional to 1 by Z. Now if we put the values of these constants, we will get for the hydrogen atom the first Bohr orbit, means which is often represented as A0, it is 0.529 Armstrong. So here n equal to 1 and Z equal to 1 here. So if we want to generalize it in terms of A0, so our A equal to 0.5929 or 5 Armstrong into n square by Z. From here you can calculate the radius of any orbit of hydrogen atom, n square, and just you have to know the n value of n square and Z. You don't have to do all these calculations. And velocity is 2 pi Z square by n. Thank you for watching. We will meet in the next class. Till then, bye.